Hello there, developers, and welcome to a new open class. I hope everything is fine. Let me know, please, in the chat, first of all, if sound, video, and everything is good so that we can continue without any issues. So, yeah, hello, everybody. Welcome back to the open classes after a couple of weeks break. So we are here back. Today we are going to be talking about AprilTags, how to detect and use AprilTags for ROS2. So it's going to be a very interesting class. So yeah, let's go for it. Let me tell you that I have a bit of throat issues, so I might be coughing more than usual during the class. I have here lots of water to keep myself hydrated. So yeah, just letting you know. All right, I'll try to keep it low, but we'll see. All right, then yeah. So hello everybody. Let me have a quick look here. I can see people saying that everything is good, all fine. All right, then let's not lose any more time. Let me switch already to my computer screen so that I can open the class page. Let me see here. There we go. All right. So let me go to the open class page so that I can have the chat already available here. Okay, I can see already quite some people. Here we have Joel from Virginia, USA. Also Marcus from Bremen, Germany. I can see Thisas also, who has helped creating today's class. So we have him here also to provide some support. All right, then let's already get started. So yeah, very first thing that we need to do, Sajat is from Canada, so yeah, we have a quite international audience today. I like that. All right, so yeah, as always, the very first thing that we need to do before we get started with the class is to get a copy of today's project. And that is very easy. All you have to do is to click here in the button that you have right above the chat, which says fork and open the class project. Okay, I have it right here. I'm going to click there myself so that I can get a copy of the project. Okay, and then a couple of things are going to happen. First of all, as you can see, you are going to be redirected to the main project page, which is the one I am right now here. And here you are going to have at the right side the streaming area, all right? So I'm going to take it out in my case, because I am the one streaming and I want to have more space here available for the project. So let me minimize it, but actually I'm going to open it again here in another tab so that I can have the chat available. There we go. Gilbert is asking, is there a date when visual odometry with RGB CAM open class will be? Not an exact date, but it's going to happen in the following weeks, Gilbert. Okay? So that class is going to be happening in the following weeks for sure. I cannot tell you an exact date, but yeah, just keep tuned to our social networks, and we will publish it as always there. Okay, then yeah. So after some seconds, as you see, you are going to be you are going to have the project page loaded as I have. And then the very first thing that you are going to see is the notebook, which gets automatically opened here. Okay? Now, besides this, there is another thing that I want to very quickly explain to you, is that a copy of this project has been also created in your account, all right? Most of you already know this, but in case that we have some new people in today's class, just to let you know that a copy of this project has been created in your Deconstruct account. And where you can find it? You can find it here in the My Projects area. In the left side menu here, if you go to My Projects, you are going to see that you have a copy of this project, of this class project. What does this mean? This means that you have a copy of this forever, basically. Yeah, so you are not going to have it only for today's class, but you are going to be able to come back next week, next month, even next year, and open this ROS project, in case that you want to review it, whatever. All right? Okay. Then, yeah, so the topic for today's class, as I already said before, is going to be perception with AprilTags for ROS2. So does everybody know what AprilTags are? Yes, no? It's a quite common concept in robotics, but let me know if you are familiar with them. Joel says yes. Also Francois, Pablo, Gilbert, nope. Okay, so we have Sajad who says nope. Okay, then yeah, so we are going to introduce them for everybody. So what are AprilTags? AprilTags are these kind of black and white images that you can see here in the robots with different patterns. Yeah, you can see also here, which is the typical AprilTag example. Yeah, so basically, as you can see, it's a pattern of pixels between black and white. Okay. Then they have many different features. Some of the key features of AprilTags are small payload capacity. For example, 12 bits. There are different AprilTags, different families of AprilTags. Okay, but they have a small payload capacity. Okay, they are designed for automatic detection and precise 6 degrees of freedom pose estimation. Okay, so from an AprilTag you can easily extract a pose. Yeah, with reference to the camera, which is detecting it. Okay, it is robust to occlusions, lighting variations, etc. Yeah, so it can be easily detected from different angles. Yeah, it can be easily detected also with different light variations. Yeah, with more light, less light, etc. It is quite robust for false positives and many more. Okay, for instance, it is very cheap, let's say. Yeah, because the important thing of an AprilTag is actually the pattern. This pattern that you can see here. This is what it contains, the information of the AprilTag. And this can be printed anywhere, for instance, in a piece of paper, right? So it is very easy and very cheap to produce. Yeah, it is robust, as you can see. It is very easy for cameras to detect them. Okay, so they have many advantages, and that is why they are very well known and very well expanded, established, let's say, in the world of robotics, among other things. Okay, and what can they be used for specifically in robotics? Well, first of all, how do AprilTags work? Well, here you have a more detailed explanation. Basically, a camera is going to detect this pattern that is unique for each AprilTag. Yeah, and this pattern is going to be decoded into an unique ID. Yeah, so each AprilTag is going to have a unique code and a unique ID associated to it. Yeah. Then, when an AprilTag is detected, we are going to be able to get this ID information, but also the pose information, okay, which is very important. Then this can be used for many different things. Ground truth data collection, robotic manufacturing, docking. Yeah, so for instance, it can be using in order to let the robot know where it is in an environment. Yeah, by placing AprilTags in different places in an environment, that is going to help the robot localize itself in the environment. Yeah, so it can be very useful for SLAM methods, for instance. Yeah, it can be very useful also for pick and place. Yeah, so you can put April tags in specific objects, and then the robot is going to know exactly what is the pose of that object. So it's going to be very easy to generate a pick and place task for an object which has an April tag on it, right? And also, for instance, you can differentiate different objects by using different April tags. Yeah, because as I already told before, each April tag has a unique ID. Okay. Also, for docking stations, for instance, you can place an April tag in a docking station so that the robot can detect very easily where the docking station is, go there, and then do the docking in order to get charged, whatever. Well, many different applications, okay? These are just some examples, but there are many more, okay? Yeah. So far, so good. Let's have a quick look at the chat here. Hello, Sai. Hello, Sai. Welcome to this open class. QR code with OpenCV. Well, here there is a section which says, so it's basically a QR code, not exactly. Yeah, so it has some things which are similar to a QR code, but it has some things which are much better. Okay, for instance, lower data density, so it is much more simple than a QR code. Okay, it's better, for instance, in avoiding false detections, etc. Yeah, so it has some similarities with a QR code, but it's not exactly a QR code. Okay. What is the difference between an April tag and a RUCO? Yeah, a RUCO markers are basically a variant of an April tag, yeah? But a RUCO markers are basically use the same concept, okay? Let me, in case that somebody doesn't know what a RUCO marker is, you can see, this is the same concept of an April tag, yeah? So, yes, basically you can see that they are the same. Yeah, it's the same idea. Yeah, so far so good. Yeah, do we have a general idea of what April tags are? Does it make sense so far? Shall we get started with the practice then? Yes. Okay. All right, then let's get started. Yeah, so we have done a brief introduction here so that everybody knows what an April tags are. Okay. Then let's go with the practice. Yeah, so as you probably already know, these open classes are very focused on practical applications, on practicing, on exercises. So today is going to be no different. And we are going to be working directly with April tags, in this case in simulation. Okay? So the goal for this open class is going to be the following. Yeah? It's our first day in our job as roboticists, and our boss has given us our first task. And this task is to work with a robot. In our case, it's going to be the BotBox in a warehouse-like environment, and we need to take it from the starting position, which is around here, in the unloading area, yeah, and then move the robot, guide the robot autonomously until a goal position, which is going to be where we are going to unload our cargo, let's say. Okay, so basically we want to move a robot from an initial position to a goal position. Okay, then we can do this in different ways with navigation, etc. But in this case, we are going to do it by using AprilTags. So alongside the warehouse environment, we have placed different AprilTags. And then we are going to use the RGB camera that the BotBox has in order to detect these AprilTags and use them to guide our robot until the desired goal position. Okay, this is going to be our mission for today. All right? Then let's get started. So the very first thing that we need to do is to launch our simulation, because right now we don't have it. So let's open a new terminal by clicking on this icon here. You are going to find it here in the bottom bar. Yeah, it's the first icon. So if you click here, this is going to open a new blank terminal. Okay? And then within this terminal, we are going to execute the following command. You can copy it directly here from the notebook and paste it here into the terminal. Okay? ROS2 launch, tortoisebot bring up, simulation.launch.py. Then we hit enter, and the simulation is going to get started. Yeah, you are going to see some log messages here, and after some seconds, the simulation is going to automatically appear. There we go. Let me make this bigger. And here we have our simulation, okay? Let me get closer. There we go. Yeah, this is our simulation with the BotBox here in the starting position, and you can see this simulates a warehouse environment with different rooms, etc. And then, as you can see, we have some AprilTags placed here in different spots of the warehouse. Yeah? Excellent. Okay. Then let's go step by step now. First of all, we are going to create a ROS2 package where we are going to be placing all our code. Okay, so let's just start by the beginning and let's create our ROS2 package. So, as you know, always we have to place the new packages inside the SRC folder of the workspace. Yeah? So, let's open another terminal. Yeah, this one, we are going to leave it here because here is where we are running the simulation. So if you close this terminal, the simulation is going to die, and we don't want that. So I'm going to actually rename this terminal to sim, so that I know that here I have the simulation running. And then you can open a second terminal very easily by clicking here in the plus button. And this is going to open a second blank terminal. Okay? There you go. So then we are going to go to the SRC folder of our ROS2 workspace. And then here we are going to create, it's the second command, we are going to create a new ROS2 package. ROS2 package create, it's going to be a Python package. This is the name of the package, AprilTag_navigation, and here we are stating some dependencies. All right? So let's execute this. And there we go. Our package has been created. Please, as always, try all this yourself, okay? So you have the project so that you can try all this by yourself. Yeah, don't stay just there looking and listening to what I am doing, but do it yourself, okay? This is why we share the project with you and we put all the steps here in the notebooks. All right? Then, okay. So at this point, I'm going to open already the code editor because we are going to start working with files and creating new files, editing files, etc. So let's open a code editor by clicking here in the second button, which says code editor. Yeah, and this is going to open a visual code editor here, so that we have access to all the different workspaces, folders that we have here inside this project. In this case, we are going to go inside the ROS2 workspace, which is the one that we are working with. And here you are going to find the new package that you have created, AprilTag navigation. Okay? All right. So let's keep going. Okay, here you can run if you want a ROS2 topic list, just so that you can have a look at all the topics that are provided by this simulation. Yeah, you are going to see the typical TF topic. We have an scan topic, which provides information about the laser, the LiDAR. We have an odometry topic, command belt topic, in order to send velocities to a robot. And here you can find the different topics related to the camera, okay? Which are the ones that we are going to be using today, yeah? Because we are going to use the camera, the RGB camera, in order to detect these AprilTags, right? Okay, let's keep going. Then we are going to create a very first Python script, a simple Python script, in order to test this AprilTag detection, okay, how this works. So let's create a new file named like this, AprilTag_navigation.py, where, well, we are going to create it inside the AprilTag navigation package and inside this AprilTag navigation folder, which already has this init.py file. Here, in this folder, we are going to create a new file named AprilTag_navigation.py. Okay. Make sure that you don't have a space at the beginning. There we go. Okay. And this is going to create, as you can see, a new Python file here, which right now it's empty, right? Because we have just created this file. Okay, so next thing to do is to copy the code that you have here in the notebook and paste it here into the file in the code editor, right? There we go. Yeah. Okay. Now, in a moment, we are going to come back to this code and explain what's going on, okay? But for now, let's keep advancing a little bit more. Now, second thing that we are going to do with our package is to update the setup.py file, which you are going to find it here inside the package, setup.py. You are going to update it in order to generate an executable from the new Python file that we have created, yeah? So we need to generate an executable from this file, and we are going to do this by editing the setup.py. Actually, what we are doing is to add this line. You can directly add this line if you want, or easier, you can just copy everything and go back to your setup.py here and replace everything, okay? Probably it's going to be easier to do it like this, right? Okay, so now what we are going to do is to do a cd ROS2 workspace. We are going to the root of the workspace because we are going to build our package, yeah? So, call build, and we are going to build the new package that we have just created, AprilTag navigation. Let's execute the command in order to build the package and to get the executable generated. Okay, now don't forget to source your workspace. And finally, we are going to run our new node, ROS2 node, yeah, that we have created with this Python script, okay? So let's execute this, and let's see what happens. Okay, let's wait a few seconds here, and we can see here that a new window has been opened, and there we go. Here, basically what we are seeing is the camera feed, yeah? So this is what the RGB camera of our BotBox robot is detecting right now, okay? So this is just a very simple Python script in order to show the camera feed, yeah? So what are we doing here? We are creating a new class named ImageSubscriber, which inherits from Node. Then inside the constructor, we are creating a subscriber of the camera image raw topic. Yeah. So this topic contains the camera feed. We are also creating an instance of the CB Bridge class. Very important. Yeah, we are importing this from the CB Bridge here. Yeah. Now, in our callback, in the listener callback, which is associated to this subscriber, what we are doing is to use the bridge in order to convert the image from ROS format to OpenCV format. Yeah? This is important. So, in order that we can treat properly the images detected by the robot, we need to convert them to CB format. Yeah? This is why we are creating an instance of the CB bridge, and here we are calling this specific method, image message to CB2, in order to convert the image to the CB format. Okay? And then once we have it in the CB format, we are showing it in a display. Yeah? And that's it. This is the first very simple program that we have created so that we can have a basic example where we are capturing the images that are captured by the camera in ROS format, and we convert them to CB format. Yeah? So that they can be treated properly. Yeah? So this is the very first step, very first example. And now we are going to start doing some more interesting things from this point. But so far so good. Has everybody been able to create the package and visualize the camera? Here? Yes, no? Any issue so far? Zemping is asking, what tool to use to generate AprilTag image? I mean, I don't know if actually there are tools to generate new AprilTags. Probably they are. But actually, you can also use, which is what we are doing here, we are using a set of AprilTags that have already been created. Yeah? So there are many sets or families. They are known as families of AprilTags, which can be used. Okay? In our case here, we are not generating any new AprilTag. We are using a set of AprilTags that are already generated. Okay? Why the conversion from ROS format to CB2 format is performed? Because this is done because in order to be able to properly, I don't know how to say this, to properly process the image and treat the image, we need to have it in CB format. Yeah? We need to convert it to CB format so that we can properly treat it, let's say. Yeah, process it, etc. Yeah, that is why we need to convert it from ROS to CB format. Here, Thisas has shared a link to, I don't know exactly what. Yeah, so is everybody okay? Have you been able to create the package, create the Python script, and run the code properly? Yes, no? All fine, says Sajat. Excellent. AprilTag generation link. Okay, so how to generate AprilTags then? All right. Thanks, Thisas. Okay, then let's keep going. Let's keep going. So we have created our first basic example, but now let's start doing some things with these AprilTag detections, yeah? Then, in order to be able to detect these AprilTags, we are going to use this AprilTag ROS package, okay? I have added here a link to the original ROS2 package, so that you can have a look here in case that you want to get some extra information. All right, you have the original package here. Okay, but basically what this package does is that it provides a ROS2 node that uses the AprilTag library to detect AprilTags in images and publish their pose, ID, and additional metadata. Yeah. So this AprilTag ROS package, basically what it's going to do is to analyze the image and detect any AprilTag that is within this image. Yeah. And when it detects this AprilTag, it's going to publish the pose, ID, and additional metadata related to the AprilTags that are detected in the image. Yeah? Then, in order to properly use this, what we are going to do is to create a launch file. Yeah? So we are going to create a launch file. We are going to add a launch file to our package. So, first of all, we are going to create a new folder inside our AprilTag navigation package. Right-click in the package, new folder, and we are going to name the folder as launch. Yeah? Because we are going to be placing inside this launch folder all the launch files related to our package. In this case, this is the launch file that we want to create. Yeah? Here you have it in the notebook, apriltag_navigation.launch.py. So let me copy the name, and then I'm going to go inside the launch folder, right-click, new file, and paste the name here. And there we go. I have created my AprilTag navigation launch file. So, final step is to copy the code of the launch file and paste it here. There we go. Okay, then what are we doing in this launch file? Very simple. First of all, let me drink a little bit. First of all, we are defining here a configuration file. Yeah. Here we are defining basically the AprilTag family, which is this one, 36H11. Yeah. This is a specific family of AprilTags, so that our AprilTag ROS package knows which AprilTags it has to look for in the image. Yeah? Then we are launching two nodes. First of all, we are launching the AprilTag node from the AprilTag ROS package. Yeah? And important here, we have to specify the topics where our camera is publishing the images. Yeah? In our case, this topic is camera image raw for the camera feed, and camera /camera info for the camera metadata. Yeah? So the AprilTag ROS package needs this information. Yeah? Otherwise, it's not going to be able to know where to get the images from. Yeah? So you have to specify this. In case that you have a different robot, a different camera, and your topics are different, you will need to change this here. Okay? And finally, we pass the parameters file, specifying the AprilTag family. Yeah? And then, second, we are launching the node that we have just created early here. Yeah? But we are going to do some modification now here. You will see in a moment. Then, next step, we need to update our setup.py in order to install in the ROS2 workspace the launch file. Yeah? So basically what we are doing here is to add this line here to install the launch file. Yeah? You can copy and paste this line, or easier, you just copy everything, go back to the setup, remove, and replace. Okay? There we go. And then final step is that we are going to also update our AprilTag navigation program. Okay, Python script. Then let's copy this code. Let's go to our Python script and let's replace it. Yeah, there we go. So as you can see, we have a few additions here. Let's quickly review here our new updated program. Okay, so we have our class with the constructor, and in the constructor we have the subscriber to the camera image raw. This we already explained it. And we have a second subscriber. In this case, we are subscribing to this detections topic. What is this detections topic? This topic is where the AprilTag ROS node is going to publish all the AprilTags that detects in the image. Yeah? So remember, we explained that this AprilTag ROS package is going to start a node which is going to check this image feed and look for AprilTags. Then, whenever it detects an AprilTag in this camera feed, it's going to publish it in a topic named detections. Yeah? So in our program, we are subscribing to these detections so that we know whenever an AprilTag is being detected. Right? Then we have our listener callback as early, where we are converting the image to CV2 and we are publishing the camera feed. Yeah? But we have an addition here. We are saying, okay, if there is a detection, we are going to draw a circle in the center of the AprilTag. Yeah? So this is why we need to convert the image to CV2, because this way we can use CV2 in order to process the image, for instance, to draw a circle in the middle of the AprilTag, which is what we are doing here. Yeah? Here you have an example of why we need to convert it to CV2. Yeah? So what we are doing here is that if an AprilTag is detected in the image, we are using CV2 in order to to draw a circle in the center of the AprilTag. Yeah? This is what we are doing here. What else? Here we have a detection callback. Yeah? So basically, this is the callback function related to the detections topic. And what we are doing here, basically, is to check if there is any detection. If there is a detection, we set this flag, target detected, to true. And we call this function, move towards tag, which we are going to check in a moment. If there is no detection, then we are going to keep the flag, target detected, to false. Yeah? And then, what are we doing if there is a detection? Well, we are calling this move towards tag function. And basically, this is a simple proportional controller where we are going to send linear and angular velocities to the robot based on the center of the AprilTag. Yeah? So wherever the AprilTag is detected, we are going to move the robot towards that detection. Yeah? So if an AprilTag is detected here, then we are going to send velocities to the robot so that the robot moves towards this AprilTag, towards the center of the AprilTag in this case. Yeah? Does it make sense? Does it provide 6 degrees of freedom of the camera or the AprilTag? No, 6 degrees of freedom of the AprilTag with reference to the camera. That is what it provides, Setare. Of the AprilTag with reference to the camera. Okay, then All right, so we have explained the code, yeah? Now let's test it. Let's test and see what happens, right? So again, let's rebuild our package so that we take into account all the new updates that we have made. Let's build again our package. Important, as always, to source. There we go, source. And then now what we are going to do is to execute our launch file, yeah? And the launch file is going to, let me remind it, it's going to start the AprilTag ROS node. And it's going to start also this ROS2 node that we have created here, yeah? So let's execute it and let's see what happens. Let me put here the simulation so that we can have a look. And let's also monitor here what's going on here, right? Okay, so here you can see that the AprilTag has been detected. Our program is drawing a point, a circle in the center of the AprilTag. And also the robot is, I don't know why in Gazebo here it's not showing, but you can see that the robot is moving towards this AprilTag, right? Yeah. So our controller is moving our robot towards the center of this AprilTag. Yeah, and now it's going to crash against it and that's it. Okay, there we go. I don't know why, probably Gazebo client is bugged here, but what matters here is the camera view. Okay, so first step is done. Let me stop everything now. Also you should stop everything. Let's just stop also the simulation. And by the way, here in the simulation, even if you stop the simulation, as you can see, probably the Gazebo client is not going to close if it is bugged, like it's my case, okay? For this, we have placed here inside the simulation workspace and a script, which is this kill GZ sh. You can use this script to kill Gazebo, okay? You can call this script, sorry, I need to change Spanish, there we go. If you call this script, this is going to automatically kill all the Gazebo related processes, okay? So you can use it to properly kill the simulation. And then, yeah, just relaunch the simulation with the same command that you used before, yeah? There we go. Okay, so first step achieved, yeah? We have created a program which is able to get the images that are being captured by the robot, by the camera of the robot, and then from these images, we are able to detect the AprilTag and move towards that AprilTag, right? So this, we have it working, right? But that is not the goal, right? The final goal we set, it was to reach this final destination here, yeah, the unloading area of our warehouse. So what can we do now? Yeah? Well, there are different approaches. There are different approaches that you can do. In this case, we are using a quite simple one, which is that we are going to be moving towards this first AprilTag, yeah? But when we detect that we are close enough to this AprilTag, we are going to stop moving forward and we are going to start rotating the robot. And we are going to start rotating until when? Until this second AprilTag is detected by the camera. Yeah? So the idea is we move towards the first AprilTag, And then when we are close enough to this AprilTag, we stop moving forward, we start rotating to the right until we detect this second AprilTag. When we detect this AprilTag, we are going to start again moving forward towards this AprilTag. Yeah? So we are going to have all the first sequence completed. Yeah? Does it make sense? Then how are we going to do this? Well, what we are going to do is by checking the AprilTag. Yeah? So we are going to check the size of the detected AprilTag. Then we are going to start turning the robot to the right if the tag occupies more than 30% of the camera view. Yeah? So as we get closer to the AprilTag is going to be occupying more space in the camera view, right? So when the AprilTag occupies more than 30% of the whole camera view, at that point, we are going to start rotating to the right. Yeah, we are going to stop turning and move towards the next tag. Yeah? And in this case, we are going to evaluate this tag as the tag with the ID 1. Yeah? Yes? So one thing that I did not show, that I might show now, yeah, let me show it very quickly, but I am going to disable the move towards. You don't have to do this if you don't want, okay? I'm just going to do it here to show you something very quickly. Yeah, so let me here recompile. I just want to show you what happens in ROS terms when the AprilTag is detected, right? So let me execute again this program without moving forward. Yeah, this should start detecting the AprilTag here, you see there. And then when this happens, if we run a ROS2 topic list, we are going to be able to see this detections topic, yeah? And then you can subscribe if you want here. Here in our program, we are creating a subscriber to this topic, yeah? But you can also do a ROS2 topic echo to this topic to see what it contains exactly, yeah? See? And here you can see what this detections topic contains. Yeah? It contains information about the family of the AprilTag, which is this family, the ID of the AprilTag. Yeah? So this AprilTag corresponds to the ID 0. Yeah? And we know that this second AprilTag corresponds with the ID 1. Yeah? Okay, just wanted to show you this. Then let me stop again the program. And let me... Yeah, so far so good. Are we following? Let me have a quick look at the chat. From all the possible markers, where do you specify that we are looking for that specific one? For the robot to follow? Or for CB2 to look for? Okay. From all the possible markers, where do you specify which one are looking for? The specific one for the robot to follow or for CB2 to look for? Okay, I believe you just answered my question. Okay. I wasn't understanding very well the question here, but if it is clear now, after my last explanations, then great. Okay, then let's keep going forward. Okay, Then we are going to use this approach that I have just explained here. Yeah. Then for this, of course, we need to update our program. And here you have the updated code. Yeah. So let's copy the updated code. And now we are going to explain it again. You are going to. So let's, again, you can select everything like this. Where it is? Select all, remove, and paste. Okay. So this is the updated code in order to reach the second April tag, which is this one here. Yeah. So what do we have here? Again, we are subscribing to the image route topic. We are subscribing to the detections topic. And now we are also subscribing to the camera info topic. Okay. Actually, this is not so important because all we are doing here is to get the height and width of the image. Yeah. But, well, we are doing it with a subscriber here. Again, we have our listener callback where we are converting the image to CB2 and we are drawing a circle in the center of the April tag detected. In the camera info callback, as you can see, we are getting the width and height of the image. Yeah, this is so that we can know when the April tag is occupying a 30% of the whole camera view. Yeah. And this is the, so we still have the move towards tag function as we had before. You already know this one. And we have added here another method to turn the robot to the right, where all we are doing is to send velocities. Yes, send an angular z velocity in order to turn the robot to the right. Yeah, and we publish this message to the command belt topic. Yeah, this is something that I think that before I didn't explain, but yeah, here we are just creating a publisher to the command belt topic in order to send velocities to the robot. Yeah, and then here we have our updated detection callback method. Yeah, so what are we doing here? Okay, if there is a detection, again we get the ID of the tag, of the April tag, as you can see here. Yeah, we are getting the ID. I think this is related with what Pep asked. Yeah, so here we are getting the ID of the detection. We are setting the flag to true. We are getting also the detection center. Then here we are calculating the area. Yeah, the area of the image view. Yeah, which is the width multiplied by the height. Yeah. Then, if the tag area, yeah, so we have here the April tag area and the whole image area. So if the April tag area occupies more than a 30% of the image view, then we are going to set the turning right flag to true. So we are going to stop moving forward and we are going to start rotating to the right. This is what the logic that we were explaining a moment ago. Yeah. Then, yeah. So once we enter the turning right flag, then we are going to check for the detection ID 1. Yeah. We know that this April tag has the ID 1. So if this April tag is detected, it means that we are going to have the ID 1. So then we are going to stop turning right. And again, we are going to call the move towards tag method. So we are going to start again moving towards this April tag. Yeah? If the April tag with the ID 1 is not detected, then we are going to keep turning. Yeah? So this is the logic. All right? Then let's compile and let's check if this works. So let's build again our program. Source. And let's launch it. There we go. Okay, so let's see what we get. It's starting to rotate. Okay, I don't know why it's doing that. Probably it's entering in the turn right to true or something like that. Probably something wrong here in the code. Okay, let me stop everything and restart it. This happened also one time earlier when I was testing. I don't know exactly why it happens. You can have a look, but I guess that there is something here which is not quite robust in the code. Okay, let's stop. Let's restart everything. Probably now it's going to work. Again, oops, there we go. Let's get closer. Okay, let me make sure that I source. And let's relaunch the program. Okay, there we go. Okay, there we go. So the robot starts with the first step, which is it is detecting this April tag, and then it's moving towards the detection, right? You put this here. Now, when this April tag occupies more than 30% of the whole camera view, the robot is going to stop moving forward and is going to start rotating to the right, or that is what should happen. There it goes. So now, as you can see, it has stopped and it's starting to rotate to the right. And now we should see that the camera detects the second April tag there. There it is, the detection, and now the robot should start moving again towards the second April tag. There we go. Yeah? So the second April tag has been detected, and we are moving towards this second April tag. Okay. All right, and now it's going to keep moving forward until it crashes against the wall, okay? Again, sorry. So now basically we have a final step, which is to detect somehow this third April tag and make the robot reach this corner, okay, where this April tag is. This is the destination. Yeah, this is the goal position for our task. Yeah. So not this one, but this one. Okay. But for this last step, we are going to leave it to you. Yeah. So you have the template code again. You can create a different method, like here. Yeah. You can update this one if you want, whatever. But this is going to be your homework, okay? To update the program that you already have in order to somehow, you can use whatever method you want, detect this third April tag and make the robot reach this goal destination. Yeah? So you should get a behavior similar to this one, where at some point, well, this is one way to do it, for instance, where at some point we are going to stop and we are going to start looking for the third April tag. Yeah? So this is going to be your homework for today's class. Yeah? This, you have to do it. Okay? You have the project, you have the knowledge. So this is going to be your task. Yeah? The task that I give to you for this class. Okay? And then you can explore. So there are many more things that you can do with April tag. For instance, here you have a little example of, for instance, showing the ID of the tag. Yeah, in the image. There are many things that you can do, so you are free. I encourage you to explore different things and improve the program, the code. Okay? But this is going to be your homework. Yeah? Let me have a last look before we get finished here to the chat. I think that we can have the TF of the tag and evaluate the post directly. Yeah, Francois. Yeah, I see that Tisas has already answered to you. If we had several markers on the same image, I assume that the detections array would show both markers. Am I correct? You are correct. Yes, Pep, exactly. All right, guys. So yeah, I'm going to leave it here then. You have the homework, so you have this last task to work on. Then yeah, I encourage you to do it and share your results. Yeah. So when you have it working, share it with us in our social media. We are always happy to see our students sharing their work with us, right? So yeah, I'm going to leave it here. Again, thanks to all of you for being here today with me in this class. I hope that you liked it. I hope that you enjoyed it. And especially I hope that you have learned something. And yeah, thanks again. I will see you in the next one. And as always, until then, keep pushing your ROS learning. Bye-bye.